This lesson is about exponential expressions. Let's review some definitions. First, an exponential expression has a base, an exponent, and an answer. For instance, 10 squared equals 100. The base is 10, the exponent is 2, and the answer is 100. So that's our example. The statement 10 squared equals 100 is an exponential expression. The base is 10, the exponent is 2, and the answer is 100. Here's another definition. Any non-zero base to the power of 0 is equal to 1. Here are some examples. 13 to the power of 0 is equal to 1. Negative 52 to the power of 0 is equal to 1. 1 to the power of 0 is equal to 1. You can pretty much pick any number you like 42 to the power of 0, and that also will equal 1. The only exception to this is our next example, 0 to the power of 0. That is undefined, just like 0 divided by 0 is undefined. Here's another definition. Any negative exponent means to take the reciprocal of the base and use a positive exponent instead. So for example, 2 to the power of negative 3 is really 1 over 2 to the power of positive 3. Or 5 to the power of negative 1 is really 1 over 5 to the power of positive 1. Or, a unique example, 0 to the power of negative 1 is really 1 over 0 to the power of positive 1, which is undefined because you cannot divide by 0. You will want to memorize the answers to all of the following exponential expressions. You should definitely become comfortable with your powers of 2, your powers of 3, your powers of 5, and your powers of 10. It will help you do exponential computations more quickly without the need of a calculator. So for instance, starting in the middle, 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 2 to the power of 5 is 32. Clearly we're just multiplying by 2 as we go up. To go downward, we have a negative exponent, which means the reciprocal. So each of these will be fractions. 2 to the power of negative 1 is 1/2. And 2 to the power of negative 2 is 1/4. And 2 to the power of negative 3 is 1/8, and so on. Likewise for the next row in your powers of 3's. 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81, and 3 to the fifth is 243. You can use a calculator to double check all of the remaining values and fill in the rest of the table. Keep in mind that 10 is very simple. 10 to the power of 0 is 1, 10 to the first is 10, and from here on in you just have the same number of zeros as the exponent. So 10 squared is 1 with 2 zeros, and 10 cubed is 1 with 3 zeros, and so on. Practice all of these powers. Solving exponential equations. Here's a definition. If both sides of an equation have the same base, then the exponents must be equal. Consider this example. 2 to the power of 3x and equals 2 to the power of x plus 8. Since the base on both sides is 2, the exponents must be equal to each other. So we can simply set the exponents equal to each other and solve for x. 3x must be equal to x plus 8. So you do basic algebra, subtracting x from both sides to cancel the x, dividing both sides by 2 to cancel the 2, and you get x equals 4. Therefore, x equals 4 is a solution to the original expression. Check your answer. Plug 4 in where x was in the original. So 2 to the power of 3 times 4, which is 2 to the 12th, which is 4,096. And on the other side, 2 to the power of 4 plus 8 is 2 to the power of 12. We can already see they're equal. But multiplying it out, we see it's 4,096 equals 4,096, which is true. And therefore, x equals 4. Here's another example. Solve for x in the expression 5 to the x minus 3 equals 1. It appears like you do not have the same base on both sides. But remember that 1 equals 5 to the power of 0, because anything to the power of 0 is equal to 1. Thus, we can create a situation in which both sides of the equation have the same base. So, our starting equation, 5 to the x minus 3 equals 1, we can rewrite as 5 to the x minus 3 equals 5 to the 0. Now, since the bases are equal, the exponents must be equal. So x minus 3 must equal 0. In other words, x equals 3. If you plug 3 back into the original expression, you'll see a true statement. For instance, 5 to the 3 minus 3, which is really 5 to the 0, does in fact equal 1. So it's true. Here's another definition. If both sides of an equation can be rewritten to have the same base, then you can equate the exponents. For example, 4 to the power of x equals 8 to the power of x minus 2. The bases are currently different, but remember that 4 is equal to 2 squared and 8 is equal to 2 cubed. So we can rewrite the equation as 4 becomes 2 squared and 8 becomes 2 cubed. Now we can use the exponent rule that x to the power of m to the power of n is really x to the power of m times n, and we can simplify. 2 to the power of 2 to the power of x is 2 to the power of 2x, and 2 to the power of 3 to the power of x minus 2 is really 2 to the power of 3x minus 6. Keep in mind that we had to distribute 3 times x minus 2. When you distribute the 3, it's really 3x minus 6. Now both the bases are 2, so we can equate the exponents. 2x is equal to 3x minus 6, and solve for x. And therefore, x equals 6. And if you plug 6 into the original expression, you will see that the numbers are equal. Here's one more example. 27 to the power of 2x is equal to 9 to the power of x minus 1. The bases are not currently equal, but we can rewrite them so they are equal. For example, 27 is really 3 cubed, and 9 is really 3 squared, so we can substitute 3 cubed for 27, and 3 squared for 9, and then use the exponent rule so that 3 times 2x is really 6x, and 2 times x minus 1, remember to distribute the 2 times the x minus 1 completely, so 2 times x, 2 times 1, is 2x minus 2, and now our bases are equal. So we can equate the exponents. 6x is equal to 2x minus 2. Solving for x, you get x equals negative 1/2. Therefore, x equals negative 1/2 is the solution to the original equation. Here are some practice problems. Solve for x in the following exponential expressions. Keep in mind that the bases must be equal in order to equate the exponents. So you will have to rewrite some of these bases so that they are in fact the same. Once you're done, go to the next screen and check your answer key.